everybody. This video is going to be the beginning to our chapter 5, which is over systems of equations. So I have a definition up here for you in the orange. A system of equations is just two or more equations with the same variables, and our equations are going to have x's and y's in them. So we'll have two equations, both with two of the same variables. Now, when we go to solve a system of equations, we're going to look at it two ways. We're going to look at and the points where the two lines intersect, okay, where they cross, is the solution to that system of equations. Because essentially we're trying to figure out when these two equations are equal to each other. Or think about it graphically as, when do these two lines share a point? When are these two lines equal? Where do they intersect? So it's going to be located at an ordered pair that will have an x and a y value. So since our equations will have x and y as variables, our solution should be an x and a y value, and we'll express that as an ordered pair. Algebraically, a solution is still a point that makes both equations true. So if I took the x and y value from that ordered pair, and if I substituted or plugged them into the original equations, and it would have to be both of the original equations, if we plugged them in, it should make both of those equations true, meaning it makes the left side of the equation equal to the right side. So we're going to focus on solving by graphing today. And we have three scenarios. We can have one solution, in which case we would have two lines, and these two lines that we have would intersect at one spot. So that one place where the lines intersect would be our one solution to the system. But it's also possible to have no solution. When we have no solution with a system of equations, it means that the two lines, the two equations we have, are parallel. So if the solution is the intersection point, parallel lines never intersect, so there's not going to be an intersection point. There's not going to be a solution. It's also possible to have infinite solutions, and in this case, we actually have two of the same lines. So if we graph the first one, the second one, if it's an identical line, would be right on top of it, meaning these lines intersect an infinite number of places. They're right on top of each other. They share all of the same points. So we have these three cases: one solution, no solution, infinite solutions. So here are the steps for solving by graphing. The most important step is probably the first one, where we have to make sure that our equations are in slope-intercept form. Remember, this is our y equals mx plus b. Once we have each of our equations in slope-intercept form, we're going to graph each equation, and then we're going to find the solution by looking for that intersection point. So let's look at an example here. All right, we've got two equations, y equals x minus 8 and y equals negative 2x plus 1. So step one, we just said, was to make sure our equations are in slope-intercept form, and both of these are. I can identify the slope and the y-intercept for each of these equations, which is going to help us graph. So let's do the top one, and I'm going to do this in green here. We have a y-intercept down at negative 8 and a slope of 1. So we're going to go up 1, right 1, up 1, right 1, and so on. And we want to get as many points as we can. We want it to stretch all the way across our coordinate plane here to make it really easy to find the intersection point. Okay, and then I'm going to backtrack as well and then connect. Okay, so here's my first line, and then we're going to graph the second. Y-intercept of 1, slope of negative 2, so we're going down 2, right 1. And then we can also go up 2, left 1 to fill in the rest of our points. So we get our points, we connect, and we have our two lines. Now remember, we said that the solution to this system of equations is where the two lines intersect. And we have an intersection point right here. We just have to write it as an ordered pair. So this is at 3 for the x value. And then we have to, let's see, we're at an x value of 3. We have to go down 1, 2, 3, 4, 5. So this is the point 3, negative 5. So our solution is an x value of 3 and a y value of -5. So let's see another example here. All right, new system of equations. Both of my equations are written in slope-intercept form again, so they're ready to graph. The top equation, y-intercept at 9, slope of 1/2. So up 1, right 2. Okay, that's as far as I can go that way, so now we have to backtrack by going down 1 and left 2. So there's our first equation. Our second equation has a y-intercept of 6 and slope of -1, so down 1, right 1. And then we can go up 1, left 1 as well. So let's connect. And then we can see that point of intersection. Okay, we just have to find that ordered pair. So it's an x value of -2, a y value of 8, so it would be -2, 8. All right, so let's look at an example where our equations don't start off in slope-intercept form. Okay, before we can graph these, we have to rearrange them and get them in slope-intercept form, which means that I really just need to solve for y. So I'm going to rewrite my top equation here in green. And to get it in slope-intercept form, again, we're solving for y. That means that I just need to add 3x to both sides. So I'm going to add 3x here so it cancels, and I have to do the same thing to the other side to keep it balanced. So when I do this, I get y equals 3x plus 8. Okay, well now I have an equation I can actually graph. Y-intercept of 8, slope of 3. So up 3, right 1 doesn't fit, so we have to go down 3, left 1. All right, so here's our equation. Now we have to do the same thing for the second, so I'm going to do this in blue. I'm going to rewrite it down here. And this time, again, we're solving for y. We need to add x to both sides. So when we do that, we get y equals x minus 2. So we're ready to graph. So after we do this, we see that the intersection point is right here. That would be at -1, 2, 3, 4, 5. So -5 for x and -7 for the y value. All right, next example here, we see that our top equation is not in slope-intercept form, but our bottom equation is. So we need to rewrite our top equation first here. So we have x plus 2y equals 4. To solve for y, we would need to subtract x first. So we'd have 2y equals -x plus 4. Okay, and think of this as a -1x, because now we have to divide by 2. When I divide by 2 here, it cancels. I'm left with just y. When I do -1x divided by 2, it turns into -1/2x. And when I divide 4 by 2, it gives me 2. So here is my equation. So let's graph here. So there's our first line. But if you look at the second equation, it's the same as what we just graphed. We just graphed this exact same line. So the second equation would be just right on top. It's two of the same lines. So we said that this is one of our special cases. When we have two of the same lines, we have infinite solutions. All right, one more example. So again, one of our equations is already in slope-intercept form, but our bottom equation this time, we need to get into slope-intercept form before we can graph. So let's rewrite it. And then to get it into slope-intercept form, we're getting y by itself. So we need to subtract x. Okay, keep in mind, this is a negative y. Don't forget the negative. And because it's a negative y, we can think of it as negative 1y, which means we have to then divide by negative 1. So we're left with y, and then if I do negative 1x divided by negative 1, I get positive 1x. 2 divided by negative 1 is negative 2. So now we're ready to graph both. So let's start with the green one here. Y-intercept of 5, slope of 1. Bottom equation, we have a y-intercept of negative 2, and again, the same slope. So if we have two lines with the same slope, we know that that means we have two parallel lines. And if we look at our graph, we can see that these two lines are not crossing. And they're not going to because they have the same slope, different y-intercept, which we know is the definition of parallel lines. So because there is no intersection point, there is no solution to this system of equations. All right, I hope this video was helpful. Please ask questions, pause, rewatch, rewind, and have a great day.